Okay, there's quite a bit to this problem, and it's not clear exactly what tools you had available that might have shortened the work shown here, but let's go through it. You've got a triangle with sides A, B, and C, where the little c is a plus b over 3, or a plus b equals 3c. And I'm using capital A, B, and C for the angles instead of alpha, beta, gamma. We're going to use, because the cotangent is cosine over sine, we're going to come up with some identities for the cosine of half an angle and the sine of half an angle in terms of A, B, and C, as opposed to these values. Okay, and you'll see why in a second. If I square both sides, multiply by 2, I've got formulas for 1 minus cosine x and 1 plus cosine x. So we're going to start with this formula from the law of cosines. The cosine of angle A is little b squared plus c squared minus a squared over 2bc. Multiply both sides by 2bc. And now here's the trick. We're going to add 2bc to both sides, here and here. And the reason we're doing that is because on the left side, if I factor out the 2bc, I get 1 plus the cosine of A, which allows me to introduce the cosine of A over 2. On the right side, b squared plus 2bc plus c squared is a perfect square trinomial. B plus c, the quantity squared, minus a squared. So here, in this next line, I replace 1 plus cosine of A with this 2 cosine squared x over 2. And on the right, this is a difference of squares, so it's b plus c minus a times b plus c plus a. And over here, 2 times 2 is 4. Question is, how did I get this? 2s minus 2a times 2s. Well, if s is defined as the semi-perimeter, that means a plus b plus c equals 2s. So a plus b plus c I replaced with 2s. For b plus c minus a, picture subtracting 2a from both sides of this equation, and 2s minus 2a is what you get for b plus c minus a. Okay, and if you divide by 4bc, this is what you get. And so there's a formula for cosine of a over 2 in terms of A, B, and C, sides of the triangle. On board 2, we're going to do similar for the sine of A over 2. I'll go a little more quickly. Start with the same cosine law, but multiply top and bottom by -1. And the reason is because we want to end up with a 1 minus cosine of A, so I can introduce sine of A over 2. So it follows the same pattern we did for cosine of A over 2. We end up with this formula right here for the sine of A over 2. So on board 3, the cotangent of A over 2, cosine of A over 2 over sine of A over 2. Here's what that looks like with those formulas we just derived. The BC's cancel out. So there's the cotangent of A over 2. We could go through the same derivation for the cotangent of B. We end up with this. And so if we multiply these two together, which is what I'm showing down here on this row, the s minus a's cancel, the s minus b's cancel. We get s squared over s minus c, the quantity squared. But we're given that a plus b equals 3c. Since s is defined as a plus b plus c over 2, that implies that s equals, I'm replacing this a plus b with 3c. So s is equal to 2c. So if I replace s with 2c, I get 4c squared 2c minus c in the denominator is c. C squared. C squareds cancel. Square root of 4, 2. Okay, that happens every time you have a triangle where this third side is a third of the sum of the other two sides. Okay, there you go. Hope that helped. If you have any questions, post a comment.